Hello, my name is Tanel Jevstignejev, and today I'm going to introduce you to the latest technology from Bitdefender, which is called Hyperwisor memory introspection, or HVI in short. But before we going to talk about HVI, let's talk about or see what's the current state of antivirus. And antivirus has been around for many years already, and over the years they have developed different technologies to catch the malware. But still, despite the different methods they are using, people still get infected. So let's look a little bit more into detail what's going on and how the antivirus works today. So basically, the antivirus today is looking for malware, and how does it do it? Just analyzing the malware when the file is being executed. Does it match any certain patterns, for example? It's called malware signatures, or analyzing the behavior. And as the malware has evolved, so antiviruses have incorporated different intelligent technologies to counter the unseen or identify the unseen viruses. Today we are facing a new kind of malware which is called advanced persistent threats, and they are designed specifically to hide themselves or for stealth. So they are hiding from the operating system processes. So by opening the task manager or process explorer, you can't find them. And another thing they are trying to do is be as persistent as they can. So even if you can remove the malware, even partly, they have different means to infect the system again. And they are incorporating really sophisticated attack mechanisms to infect the operating systems or the machines and avoid detection. And another issue is that the malware is constantly evolving these days. So malware has become more like a business model. So you have malware as a service where you can just pay some money and you can get yourself a brand new malware which has never seen before. And if you look at the statistics, then nowadays most of the malware is only seen once. And another thing is that the malware production is being automated. So you have different automated scripts just to pump out new malware every day. And the malware developers, they have their own QA team. So they are constantly testing the malware against the latest antivirus software. So they're testing again, and retest until the antivirus can't identify or catch the malware. And maybe the last issue to point out is that you can only detect and catch things you can see. So if the malware can hide themselves from the antivirus and from the operating system, then you might even know that the system is compromised. And this provides like the false sense of security to you. And the advanced malware is using advanced techniques to get a foothold in the systems. But the thing is that the number of techniques actually is quite low. And if you look into these techniques, then I'll just briefly go over a couple of these. For example, buffer overflows, where the malicious program writes to a buffer which is not intended to, or heap sprays, where the malware tries to insert their data to certain areas in the machine memory, or code injection, where you inject just code to DLLs or EXEs to be executed. And then other techniques which you can use to get or compromise the system, and usually they are part of software, mainly software bugs, which are being used to install rootkits, 0 days, and execute kill and exploits. And now when we are talking about data center security, then the real revolution came with virtualization. Back in the days, data centers were running a lot of physical hardware, and obviously that wasn't really efficient. Thanks to virtualization, data centers were able to consolidate the machines, and the business became more efficient. Moving from physical to virtual, obviously they transferred over the antivirus part as well. So traditionally, virtual machines were running full agents inside. So obviously they provided some kind of antivirus protection to the systems, but still you had a lot of wasted resources there. The model itself stayed the same. So you had the antivirus agent, you had the operating system and the security filters in the kernel. Model itself stayed the same. And probably some of you have experienced the storms, for example, scanning storms or update storms in your infrastructure, when you discover that for some reason your servers or workstation have been really slow running in the virtual machines, because all the agents inside virtual machines started scanning or they started updating at the same time. So this was a really huge headache for data centers. So that's why the central scanning was developed. So to ease these pain points, and with central scanning came Light Agent. So what Light Agent does or enables is to offload the scanning resources to a central server. So you can save a lot of resources in the virtual environments. But again, the antivirus model is the same, because again, you have some kind of agent, although lighter, in the system. So the central scanning eliminated the AV storms. The management became simpler because all the updates, the central server was hosting all the updates. Also, the scanning became clever because central scanning was, first of all, offloading the antivirus resources to the central scanning engine. Also, you don't have to scan the same files over again, so saving a lot of resources. And maybe the central scanning effectiveness is also comes apparent in virtual desktop environments, where when you have the golden images and so on, then only the changed blocks are being scanned. And the last part, maybe the last advantage, is faster protection. And especially this is important in virtual environments because, for example, if you have a virtual machine which hasn't been used for quite some time and you start it up, then the antivirus definitions are outdated and the machine is not protected as efficiently. Or second thing, when you do a virtual machine rollback, then obviously the definitions will be older. So again, the machine might not have the best protection available. Another form of central scanning is agentless scanning. So this works that into a virtual machine, with the Hyperwisor software is installed a security driver, which helps to offload the antivirus scanning to the central appliance. But the limitations here are set by the driver itself from the Hyperwisor. So depending on the situations, people use different options, either light or agentless. And same with agentless scanning. So it's actually not agentless because you still have the driver or let's call it agent still in the virtual machine. And the antivirus model itself still stays the same. So to sum everything up is that existing antivirus solutions, even in virtual environments, although thanks to all the development which has been going on, still act as a normal antivirus. So they are agent-based and they are looking for files, so they are still scanning the files inside the virtual machines. And another big impact is that you can't really efficiently scan the memory inside the virtual machines. So because it's really costly to do it. And nowadays the growing trend is that advanced malware even they don't have to touch the hard disk at all, so you don't have anything to scan. And they are just staying in the memory. So without this kind of protection, machines can possibly become compromised. So if we look at the different protections antivirus is providing nowadays, like application sandboxing, all anti-malware engines, or application whitelisting, and the list goes on, then still they can be avoided using, for example, OS kernel exploits. And if you look at the history of kernel exploits, then we can see that there have been quite many of them. So this brings us to the point that we can't really trust the OS, because the thing is that antivirus trusts the operating system and uses the APIs there to do their work. So when the operating system becomes compromised, the antivirus can't be trusted anymore, because once you're relying on the operating system, and they might get some false information. That's exactly the thing that the rootkits and advanced malware is trying to do. So they are both running on kernel level, which is called ring 0, and they're competing with each other. So once the malware gets foothold and is able to, for example, disable the antivirus product or modify it, then we're going to have an issue. Now, coming back to the HVI or hypervisor memory introspection, this is really a revolutionary thing in the data center, because it's not relying anymore on the traditional ways of detecting malware and looking and searching for it, but it concentrates and focuses on the attack techniques. So as we mentioned, there aren't that many techniques available. So this solution will be really effective. How does HVI work? For example, on Xen server, it uses the direct inspection API provided by Xen server Hypervisor to directly inspect the memory inside the virtual machines. So this means that the solution is agentless, so it doesn't use any agents inside the virtual machine itself, and it runs even lower than the kernel or the virtual machine itself, using the isolation provided by Hypervisor. The security solution has higher level of privileges as the malware or the operating system. Another thing in the modern security environment is the dilemma of context versus isolation. So for example, the network intrusion detection systems and web application firewalls, they provide really good isolation from the workload or the virtual machines themselves. So they have really good isolation. But then again, they are lacking the context of what's going on inside the workload or virtual machine. Or they don't know what's going on in the virtual machine's memory, for example. Then on the other hand, antivirus products running inside the virtual machine, they have really good understanding of the context. So they scan and see what's going on, but they lack strong isolation because they are running inside the virtual machine, and once the machine gets infected, then the isolation is gone. So by using these technologies, the Hypervisor, for example, is providing really good isolation, first of all, for the security appliance. And on the other hand, the direct inspection API giving access to the virtual machine memory provides a rich understanding of the context. So this solution can really protect against really or entirely new malware types. And how the HVI actually works, it's leveraging the extended page tables, which the Intel processors provide, to map the memory or create a memory map using hooks of 4K memory pages. A set of rules is created. So how it actually works is that in memory you have different areas where you can write to or which you can execute and read from and so on. So the solution maps these areas and creates rules. For example, that dynamic heap, for example, shouldn't be able to execute programs. So if it does, or the malicious software tries to do it, then it's being caught. So this gives you a really good visibility in your infrastructure and in your systems, And this system also has a complete control over what's going on in the memory, what can be executed, where the process can be write the data, and so on. And this is all backed by security logic, which orchestrates all these actions. Let's have an example, for example. So if a virtual machine gets infected, or the software inside gets infected, then the virtual appliance will be able to detect it and block the activity or sandbox it. So you can really run a forensics, for example, and to be able to see what was the intention of the malware and how it was going to react or act in your system. And if configured, then as well, remediation tool can be injected directly into the virtual machine memory, which will do the scanning of other processes in the system. So this provides you another layer of security, because you can, since it's injected directly to the memory, then the security agent itself, which is being injected, can't be compromised by advanced malware. And how you can use the HV, or you can use the HV to secure your entire data center, for example. So once deployed, you can protect all your virtual machines in the environment. HVI already has proven itself by blocking the really high-profile malware which is in the wild today. For example, Carbanock or APT28, WannaCry, Zeus, and so on. So HVI uses two-layered model, so you can protect the user mode, where all your programs run, for example, so you can secure your Office programs or Adobe browsers, Java, and so on, to stop the malware in the user mode already, and you can protect the kernel from kernel or different malicious driver injections, for example, or kernel modules, and so on. So providing these two layers of security has already proven really efficient. And now let's have a look at the couple of the attacks which has been in the wild lately, and how HVI can block these attacks. So let's first look at the Carbanock APT, which infected many financial institutions and caused damages and losses up to $1 billion. As we see today, clients were infected by using spear phishing methods, by sending emails, malicious email. The user opened the email, and using the vulnerability in Microsoft Office, the malware was able to execute executable and deploy some files in the system. But as soon as the malware tried to actually inject something, then HVI caught the malware and cleaned it up. And the second example we have is Torla APT, which infected really high-profile government and military organizations all over the world, affecting close to 45 different organizations. Again, spear phishing was used. A malicious file was sent via the email. In this time, as soon as the user opened the attachment or executed the malware, and the malware tried to insert kernel drivers, the HVI was able to stop the attack. Now we're going to show you a small, really quick demo about the HVI in action. So we have a Windows 7 machine here, and we are going to use a Mozilla web browser, and it has Flash installed, but the average setup user have nowadays. And by directing the customer to a specially crafted website, we are able to infect the customer. So now the malicious website is being set up. The affected machine or the not protected machine is going to browse to the affected site. And now, since and thanks to using the Flash exploit, the attackers get access to the customer machines, and they are able to execute different commands there. Get information, download specific files, or even install additional tools to infect the customer environments. And now let's look at the how HVI can protect the machines. Now we are trying to browse inside the protected machine, and again customer goes to the infected site, but it gets blocked, and as soon as that happens, also Bitdefender security tools will be injected into the customer virtual machine memory. And once the tool finishes scanning, it removes itself from the customer machine. So this brings us to the question, should we completely get rid of the normal antivirus products, for example? But this is more like comparing apples to oranges. The antivirus runs inside the guest machine, and in some circumstances it might have some performance advantages. They're still focusing protecting the file system. We still think that's really important to be able to scan the file system. They are relying on the in detection of patterns and behavioral analysis, machine learning and so on, but they still rely on regular updates. For example, weak point is that the protection can be evaded. Then compared to the HVI, for example, then thanks to HVI, you can improve the security of your environment. And the HVI focuses on protecting the memory of virtual machines and focusing on techniques. Advantage is that it doesn't rely on regular updates. And thanks to the strong isolation, for example, and the understanding of context, then HVI has great visibility. But the thing is that they're meant to work together, so they complement each other, for example. So even if you have the normal antivirus inside the virtual machines, then you can just enhance the security of your environments, and by HVI, for example, you can guarantee the OS kernel integrity or improve the security visibility in your systems. And as well, thanks to strong isolation, the HVI virtual appliance can be a really reliable source of information and events. Another maybe really important thing is that when incorporating these both areas, then you can drastically increase the cost of an attack. So it might take a lot longer of the adversaries to attack your system or penetrate it. Thanks to HVI, you can keep the antivirus software safe as well. And today, the HVI can be used in several platforms. So all the newest Windows operating systems can be protected by HVI, and Linux environments as well. So only thing you need from the hardware side is Sandy Bridge or newer Intel CPU, and at the moment, Xen server. But hopefully in the near future, other hypervisor vendors provide similar functionality as well. Thank you for watching, and it was my pleasure to introduce you to this revolutionary technology from Bitdefender. Thank you.